All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. How's everybody doing? Good?
Yes, Mr. Q.
All right, good. So warm-up number 46 is on the screen. Number 1 reads, complete the squaring factor, and they give us the binomial x squared plus 14x. Number 2 reads, simplify, and they give us square root of -9. Number 3 reads, add, subtract, multiply, and divide, and they give us two binomials. One is I minus 5, and the other one is I plus 2. And number 4 says, find the inverse of x of the given function f of x. And for part A, they give us the function f of x equals x plus 2 over 5. And for part B is f of x equals 2/3 x minus 5. I'll give you about 4 minutes to finish that. Copy and go. See. Just in case you didn't get that, here goes for number 1. We have a binomial and we need a trinomial. That means we need one more term. And how do we complete the square? We take the coefficient of the middle, divide it by 2, and then square it. That gives us x squared plus 14x plus 49. This is a perfect square. What do we do next? We factor. We got 49, 14. What two factors of 49 add up to 14? 7 and 7. That's why we can write this as x plus 7 squared, because it's a square. That's why it says complete the square. You're like, what? Number 2, Juliana. 3i. Hands if you got that. That is correct. Once again, square root of -1 times square root of 9. Square root of 9 is 3. Square root of -1 is I. Number 3, I'm going to do addition in blue. So I got I minus 5 plus I plus 2. Since there's nothing outside parentheses to multiply, just combine. What is I plus I? 2i. What is -5 plus 2? -3. Technically we're done, but since this is a complex, the constant goes in the front. So this is written as -3 plus 2i. Need to get used to that notation because we're about to get into complex numbers now. Yay! Alright, I'm going to do subtraction in red. Let's see, we got I minus 5 minus I plus 2. So what does this minus do? It distributes to the second parentheses. Remember that? Yes? So that is -I and -2. So now we combine. What is I minus I? 0, right? This cancels that. And then what is -5 and -2? That's -7. That's the difference. Okay? Let's go to multiplication. I'm going to do multiplication in green. Let's see. Distribute. What is I times I? I squared. What is I times 2? 2i. What is -5 times I? -5i. And what is -5 times 2? That's -10. Can I combine stuff?
Yes, Mr. Q.
What is 2 minus 5i? That's -3i. Bring down the -10 and bring down the I squared. Are we done? No, you guys, hopefully you remembered, right? You're like, oh yes, Mr. Q, we did this like for 2 weeks straight. And I remembered to substitute for I squared a value. Yes? You guys remember that value? What do you think? Noor? Audrina? What? -1. -1. I squared is -1. Tell your neighbor what I squared is. Alright, so let me bring everything else down. -3i minus 10. Now I can combine -1 and -10. That's -11. Bring down the -3i. And this is my final complex number. So I'm bringing these back so you guys can remember how to do the process for that. Alright, let's go with division, your favorite. Yeah. So what is my dividend? My dividend is I minus 5 divided by, what is my divisor? My divisor is I plus 2. Okay, let's see. Question. One number times I gives me one I. 1. Okay, so 1. 1 times I is I. 1 times 2 is 2. And then we're going to subtract, which means we distribute this to both of these. Yes? Is it coming back? Some of you, you're like, oh yes, Mr. Q, my favorite. I minus I cancel. And let's see. What is negative 5 and negative 2? Negative 7. So our what? Our remainder. Okay, and how do we write our answer? What is our quotient? 1. And then, since we have a remainder, we do plus a fraction. So what's my remainder? Negative 7 over what? I plus 2. Yeah. This is our quotient. Yes? Yeah, so let me revisit that. So the question was, when we have an I squared, we just substitute negative 1 for that? Yes, because the I squared is that. Now, Mr. Q, how did you get that? I forgot. Well, we said that square root of negative 1, repeat that again, square root of negative 1 is what? I. Okay. So, which means to cancel this squared, if I wanted to cancel this squared, I need to square this side. Is that correct? Whatever I do to one side, I do to the other. So if this cancels this, I end up with what? Negative 1 equals I squared. That's why anytime you see an I squared, you substitute a negative 1. Alright? Alright, so here we go. Let's go to the number 4. By now, you should be experts at inverses, yes? Right? Right, Philip? Yeah? We good? So, what do I do here, everyone? Very good. Substitute y for f of x. Oh my goodness. We've been doing this for 2 weeks, guys, and today's the day of that session. Over 5. All right, let's get rid of the 5. How do we do that? Multiply times 5. Multiply times 5. We end up with 5y equals, this is a giant 1. We're left with x plus 2. Am I done? No. Minus 2 minus 2. We end up with 5y minus 2 equals x. Is that the inverse? No, we just solved for x. What makes it the inverse? When you swap them or switch the variables. This is what makes it the inverse. So this is f of x, 5x minus 2 equals y. And now we just need to change the y to function notation. So we write function or inverse function of x equals to 5x minus 2. That's the inverse. Let's do the other one. Let's see. Change it once again to y equals 2/3 x minus 5. Let's get rid of the 5 to leave x by itself. So we add 5 to each side. Add 5. We're left with y plus 5 equals 2/3 x. So 2/3 is multiplying x. How do we get rid of that 2/3? We multiply times the reciprocal. What is a reciprocal? 3 over 2. Why, Mr. Q? What is 3 times 2? 6. What is 2 times 3? 6. What is 6 over 6? 1. That's how we get rid of it. But we need to multiply the other side times 3 over 2. So over here, this is a giant 1. So we're left with x equals, distribute, that is 3y plus 15 and all that over 2. Is that the inverse? No, we need to exchange the variables. 3x plus 15 over 2 equals y. And now we just need function notation, so it's f inverse of x. And what's on this side? 3x plus 15 over 2. Alright, and those are our inverses. Alright, so for a first day of our week, is that okay? Yeah? You guys good? Yeah? Alright. Alright, agenda for today. Warm-up number 46. Today we're moving on to inverse functions. You're like, oh snap, Mr. Q, oh snap is right. Today's going to be a day packed with a bunch of stuff. And your home plate pages 53 and 54 only. And reminder, tutoring after school, be there or be elsewhere. And by the way, tutoring is free.
Thank you, Mr. Q.
You're welcome. Yeah, I got you. All right, let's see. Nearpod code BQPKL. 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 So if you fall behind on the notes, make sure you go to that and get the rest of the notes from there. Okay? So everybody got a graph paper as you walked in? Yes, is that correct? Okay, good. And your previous home play, I gave you guys a day off. Everything. I gave you guys a full day of making up stuff. I mean, not making up stuff, but anyways. And then no home play also? Let's go. I'm pretty sure everybody's all caught up, right?
Yes, Mr. Q.
All right. Shall we? All right, here we are on your Cornell notes. We don't need a Frere model. Once again, loosen up your wrist because there's a lot of stuff that we're going to do today. We're moving on to funner stuff. And it reads, I can identify and graph an inverse of a function. I can identify and graph an inverse of a function. I can identify and graph an inverse of a function. So we're still on the same idea, which is what? Functions. But today we're going to be identifying and graphing inverses. So, what was it? Yeah? Oh, can you turn off the light so it can go back out? Okay, door, please. Thank you. All right. So, y'all ready? All right. So, function. Tell your neighbor a definition in your own words of a function. Something like that. We don't have to make a Frere model. Tell your neighbor is the definition of a function in your own words. All right. Pretty good. I heard relation and one-to-one or something like that. Yes? All right. Good. Very good. Yeah, you guys are on the ball. All right, copy this on your Cornell notes. Example Q, it reads, identify the inverse of a function using a mapping diagram. Copy the instructions, please. Example Q on your Cornell notes, identify the inverse of a function using a mapping diagram. Identify the inverse of a function using a mapping diagram. So, just as you're finishing copying that, just recap, when we got started with functions, I remember that I gave you 3 different representations. A table, using the coordinate plane, and then the mapping diagram. We're going to come back to it today. Ready? Here it goes. So let's say I gave you this function. Look up. Function. The domain, -4, 0, 1, 4. And then I gave you the range, -2, -3, 2, and 1. And of course that maps to that, that maps to that, that maps to that, that maps to that. Okay, there it is. So, writing utensils down, look up to the screen. So this is my function. Bless you. This is my function. Pay attention to this part. But they're asking me for the inverse. Okay, let's think back to the warm-up. We've been working with inverses for 2 weeks already. What makes it an inverse? What was the one thing that made it an inverse? Talk it over to your neighbor. What made it an inverse from the other? What made it the inverse? Let's see. What made it its inverse? Raymond. The X and the Y, what happens to those? You're right, but what do we do with X and the Y? I'm sorry? Adrena, what did he say? What did he say? They're both what? I can't hear. Multiplied? Okay, close. What do you think, Andrew? They switch places. Therefore, if I was to ask you for the inverse, tell your neighbor what you would write for the domain right here. Andy, what would we write? That is correct. Copy that down, please. And of course, if that's true for the domain, tell your neighbor what you would write for the range. Yeah. Be nice. -4, 0, 1, and 4. That is correct. You're like, that's it, Mr. Q, that's it. Because they're trying to convey the idea that we need to do what? Exchange the variables. That is correct. That's what makes it the inverse. So up to right there. Your home free's going to have a couple of these. From 1 to 5, how comfortable are you with these? You're like 5, 5, 5, 5. Yes. So if I give you another one, you should be able to do that one completely. Yes? Example super Q. Let's see. No, mega Q, mega Q. Copy this function. For the domain, we got -1, 0, 1, 2. For the range, we have 3, 4, 5, 6. And they map exactly one to the other. There it is. All right, and I want you to write the inverse by yourself. Do that right now, please. Copy in. Carlos, what is the domain of the inverse? 3, 4, 5, and 6. Hands if you got that. All right. So that means for our range, what will we write, Pamela? Yeah, -1, 0, 1, and 2. All right. So from 1 to 5, how comfortable are you with these? 5, 5, 5, 5, 5. Yes. Oh, 1. Anyways, so we're done with mapping. Let's go now to their graph. Yes, get your graph in front of you. We're going to use the two small ones in the back. Copy this next one, please. Example super Q. And it reads, there's a typo here. It should read graph. So write example super Q, and then the instructions are to graph. And they give us a set of -4, -2, 0, -3, 1, 2, 4, 1. Only copy that, and then we're going to do the next step together. Once again, it says example super Q, graph, the set of -4, -2, 0, -3, 1, 2, and 4, 1. All right, let's plot those. Yes, here we go. -4, -2, -4, -2, 0, -3, 1, 2, 4, 1. We good up to right there? You're like, Mr. Q, piece of cake. All right. With red, I want you to write, then graph the inverse. Then graph the inverse. So, if I was to graph the inverse and they don't give me anything, they just give me the function, tell your neighbor what you're going to write for the inverse before you graph it. Talk to your neighbor, what are you going to write for your inverse? Say your neighbor, please. All right, let's see, help me out. Lewis, what do I start writing here for my inverse? -2, -4, comma. -3, 0, comma. 2, 1, comma. And 1, 4. Hands, have you got that? Yeah, okay. All right, let's plot those. -2, -4, -3, 0, 2, 1, and 1, 4. Also, with your blue pen, let's graph a line that's perpendicular here, that's going through y. It's called y equals x, going through the point of origin, like so. Not perpendicular, parallel, my bad. Parallel, diagonal, sorry. All right, and we're going to label this one y equals x. All right, look up to the screen really quick. So let's say you're at your, wherever you do your home play at home. I'm pretty sure you get home right away and do your home play. Appreciate that. And you're there seated, you're eating your flaming hot Cheetos, and then you're plotting these. So here's this one, its inverse is this one. Here's this point, its inverse is that one. Point, its inverse, point, its inverse. And in walks your little cousin that always takes away your chips, right? So here they come in, elementary kid, and you're going to tell them one word. You're like, well, look at this line, because they're asking, what are you doing? And you're going to tell them, look at this blue line. This blue line is doing something with these. What would be the one word that you would tell your little cousin it's doing? Talk about your neighbor, please. What is it doing? All right, good conversations. Let's see, Sky, what do you think? It's what, I'm sorry? It's splitting it, yes, that's one thing. How about Carlos?
Yes.
Another word. It's flipping them, okay. Okay, we're getting close, Juliana. Reflects. Reflects. Let's write reflect, and we're going to write the word mirror so you can remember. It's reflecting. Let's see if it's true. Look at this point. Is this reflecting off this y equals x? Oh yeah, there it is. Look at this one. Look at this one. I don't know. Let's see if any of you are kind of weird like me. Has anybody I don't know. Have you ever been in front of the mirror and you know how sometimes you're, let's say in your living room or in the bathroom and there's tiles? Have you ever counted the steps for your reflection from the mirror and you from the mirror? Very good. All right. I guess it's just me. I'm always thinking numbers in math. I don't know why. Watch. Whenever you when you get home, I want you to go to the mirror and count your steps away from the mirror, and you and the mirror are going to be the same distance away if you really look at the... Never mind. All right, let's go to the other little graph next to where you're at. See if you can do this one by yourself. Example, Shazam Q. There's the function, and let's graph the inverse. Let's graph the inverse. I'll give you some time for that. Also write the y equals x graphs to see if it's doing the mirror portion of it. Copy that in. Oh, you guys are funny. All right, so we got -3, 9. Let's see, -3, 9, -2, 4, -1, 1, 0, 0. So far, so good, yes? And then the inverse, you should have written what? 9, -3, 4, -2, 1, -1, 0, 0. All right, so then here, 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 and there. And then once you graph your mirror going through the center, are they reflecting one another? Yes? Yeah, this one's reflecting this one and vice versa and so on and so forth. Okay, from 1 to 5, I'll come to bother you with these. So the first two examples, yes, 5, 5, 5, are in the home plate. I'm giving you about 2 or 3 of each. You're like, piece of cake, Mr. Q. Y'all ready? Okay, here comes the doozy. Okay, I'm giving you a heads up. So if you only have half a page on your Cornell notes, I'd rather you start from scratch a new page. Here we go, copy this one. Example, Michael Jordan Q, and it reads, find the inverse function of f of x, f inverse of x for the given function f of x. Use composition to verify that the function's I-inverse, then graph the functions and its inverse. So we have three things to do. We need to find the inverse of a function. Do we know how to do that? Yes, Mr. Q, we've been doing that for 2 weeks on the warm-ups. Thank you very much. You're welcome. I got you. Second part, use composition to verify the functions. This is the one that's going to give us a little bit of, how can we say in math? Problems. See what it did there? Never mind. Then graph the function and its inverses. We're going to graph that at the end on the big graph that you have left. But copy all of this with the instructions. I'll give you some time. Copy that. So, according to the instructions, the first part, we need to find the inverse. Do we know how to do that?
Yes, Mr. Q.
All right, so let's get started. Let's do this part together. So, I'm going to start with blue. So, help me. What do I do? Y, that is correct, instead of f of x, and I bring everything else down. Negative 3x plus 4. Then, solve for x, so what do I do? Minus 4 minus 4. We end up with y minus 4 equals negative 3x. Next, divide by negative 3, divide by negative 3. Giant 1, that leaves us with x on this side, and then we have y minus 4 over negative 3. Is that the inverse? No, tell your neighbor what makes it the inverse. Everyone? Switch the variables. That is correct. So that gives us x minus 4 over negative 3 equals y. That's the inverse, but can we leave it in that notation?
No, Mr. Q.
So what do I write instead of y? S inverse of x. And that leaves us with x minus 4 over negative 3. This is the inverse. Inverse. Okay? All right. From 1 to 5, how comfortable are you to write there? Yeah, 5, 5, 5, yeah. Really? So I'm over here, everybody's like 5, 5, 5, and I turn this way, and Raymond's off. 1, my goodness. Anyways, so, are we done? No, that's only the first part. What's the next part? Use composition to verify that the functions are inverses. You're like, oh snap, what does that mean? Check. All those words just means to check. So let me show you really quick before I jump straight into that. So writing utensils down, look up to the screen. Stay focused, please, because I tell you this, if you're a little bit distracted or on your phone, you might get lost with this one. All right, here we go. Watch. I'm not going to start yet. I'm going to show you something on the right side. You don't need to copy this. This is just to clarify. Ready? Let's say I gave you two equations. Y equals x, and in red, y equals x. You're like, wait a minute. They look almost the same. No, the other one's red. But I said that I was going to substitute one into the other, and then the other into the other. So first I'm going to substitute this one in here. So instead of y, what would I write? X, is that correct? And that should equal to what? To x, because all I substituted was a y, yes? Alright, so did we get x at the end? Yes? But what if I went the other direction? I wanted to substitute this one over here instead. What would I write here instead of y? X and equal to what? X. Now, did we get x at the end for both? Yes, that's how we check to see if one is the inverse of the other. At the end, we have to end up with x. Okay, so now let me show you the next part, because this is the part that's going to be fun. So stay focused, please. Ready? Here it goes. I'm going to start with f of x. But to verify that the inverse is the inverse of f of x, and you're just paying attention, yes? Instead of substituting x, I'm going to substitute the inverse in here. And at the end, it should give me just x at the end. Are we there? Okay, so just pay attention and you'll copy right after. Focus, please. Here it goes. So I'm going to start with f of x. What is f of x? It's all this. So watch. I'm going to write it. F of equals -3 plus 4. Do you see this here? Yes? But instead of x, what am I substituting in here? The inverse. So watch. I'm going to write f inverse of x. And here, instead of writing f inverse of x, I write the other side of the inverse. What was the inverse on the other side? X minus 4 over -3. X minus 4 over -3. Stay focused. Here it goes. So, here it goes. F. I'm just going to write the inverse because this is only a label to tell me what I'm working with. So, here we go. I'm going to zoom in. All right. What is -3 times x and -3 times -4? That is -3x, and then -3 times -4 is 12, and all of that over -3, and then I just do plus 4. Are we there so far? All right, next. Let's see. What is -3x over -3? X. What is 12 over -3? -4, and I bring down the plus 4. You're like, oh snap, Mr. Q, I think I see it. I know, right? So, can we combine like terms? Yes. What is this right here? A zero pair, and we're left with? Did we end up with what we said we're going to end up? Yes. Copy that, please. You're like, what? I know, right? All right. All right, let me zoom out to see where we're at. We started with from Michael Jordan Q, and they said to find the inverse. We took that function, changed it to y, solved for x, switched the variables, that made it the inverse, but then we wrote it in function notation, f inverse of x, and it gave us this. Okay. But then they are asking us to verify, or using composition, which means using algebra, and you need to check to see if at the end we get x after we substitute each other into each other. However, notice we did get x for this, but we started with what here? F of x. Well, now we need to substitute the opposite direction. You're like, what? Yeah, now we need to start with f inverse of x. You're like, oh snap. Yeah, so I'm going to write f inverse of, and at the end I should get an x. But what do I need to substitute in here? F of x, which is the original one. You're like, oh snap, right? Am I right? Am I right? So watch. Focus, please. Once again, if you're a little bit lost, you need to focus. That means I need to write my original inverse function. What is my original? It's right here. So I'm going to write f inverse equals, what do I have over here? X minus 4 over -3. Where did I get this from? From here. Look up. This is here. Do you see that? All right. But now instead of x, I'm going to substitute what? F of x for this side. So on this side, what is f of x? This, negative 3x plus 4. Copy that, please. Let me zoom in. Look at how beautiful that looks. Like a shirt or something, right? Q merch. No. Juliana, that'd be nice. You wouldn't buy a shirt with that? Right? Yeah, there you go. Alright. So, let's see. We started off first with f of x. We substituted the inverse instead of x over here. But here we start with the inverse and we substitute f of x. Alright, so the left side is going to stay the same because it's just a label. But the right side is the side that we're going to simplify every step of the way. So let's see. Look up. Is there anything outside of the parentheses that we need to multiply inside? No, that means we can combine like terms. Is that correct? Yeah, so what is negative 4 plus 4? It's a 0, yes. So cross this out. That leaves us with negative 3x, which is there, over negative 3. So, what is negative 3 over negative 3? Yeah, we're left with x. Did it check? Yes. You're like, what? What just happened? I'm telling you, I don't know. It's like I wake up and all of a sudden all this comes together. Pretty good, right? Look at it. So for tonight, this is what you're going to do. They're going to give you a function. You need to find the inverse. You know how to do that? Yes. Then you need to verify that they're inverses. So watch. So you start with f of x, substitute the inverse, simplify, and you should get it equal to f. From there you start with the inverse, substitute f of x, and then you should get x at the end. Be nice, Adrena. So, let's go to the graph. Get your big graph in front of you, please. The funnest part of the whole thing. Yay! I'm going to write my two functions. Let's write them. I'm going to write them right next to here so I can zoom in. I'm going to write f of x equals negative 3x plus 4. And for my inverse, I'm going to write f inverse of x in red equals negative 1 over 3x plus 1.3. Now, where did I get this from? From here. I just brought the fraction to the front so it can be our slope. 1 over negative 3 is the same as 1/3 x, and negative 4 divided by negative 3 is 1.3. All right, let's graph that. Yes? All right, I'm going to zoom in. Here we go. Start with the black one. Let's see if we remember how to graph linears. We start with my y-intercept. So we circle the positive 4. Where's my y-intercept? Right here at positive 4. What is my slope? Negative 3 over 1. That means 3 steps down, 1 to the right. So I go 1, 2, 3, 1 to the right. Plot your point. Do it again. 1, 2, 3, 1 to the right. Plot your point. Graph your line. All right, let's graph our line. Well, not blue. There it is. All right, let's graph the red one now. We're starting at 1 1/3. 1 1/3 is about right there. And then this one's going to go 1 down, 3 to the right. So 1 down, 1, 2, 3. Let's do one more point. 1 down, 1, 2, 3. We'll scrap our red line. And to check to see if they're inverses, I want you to graph your y equals x going diagonally. This is our y equals x. Is it mirroring one to the other? Does it look like they're a mirror of each other? Let's find out. Look up. This one has a point here on the y, and it's at 4, yes? So there should be a point over here on the x at 4. Is that correct? Let's see. There it is, Mr. Q. It is crossing through there. Oh my goodness. You guys see it? How about here? The y is at 1.3. That means there should be a point at 1.3 of x. There it is. You're like, what? So, let me zoom out. Did we do all three parts? Find the inverse. Check to see if they were inverses of each other and they have to equal to x each. Yes. Did we graph the last part? Yes. From 1 to 5, how comfortable do you feel with these? 5 4s, 5 4s. That's going to be your home plate. All three different examples are in the home plate tonight, pages 53 and 54. Tutoring after school, it is free. Be there or be else. All right, have a good one, everyone. Enjoy your home plate. See you guys tomorrow. Bye.